Okay, 2B is long. I'll just preface that right now. There is a ton of information and we'll take a few days to get through it. But this is getting into the graphs now. So your basic graph, if we look at a table of values for y equals basic x squared, so every x that I plug in, I just square it, and those are my y values. So we see it has a basic shape of a parabola. So one thing I'm going to say, when you have a graph on an IB test, making a table is always a good idea if you have an equation. You don't just have to sketch it. Actually take each of the x values, plug them into the equation, and make your graph. All right, so here's a whole bunch. I want you to put this right on that first page, right on with B. Copy this picture, and I just labeled everything. I will say if you want any of this stuff over here, probably the basic graph is called a parabola. This is your vertex. The axis of symmetry goes through the middle. If the parabola is facing upward, we consider the vertex to be the minimum. If it would go upside down, the vertex would then be the maximum. You have your x intercepts and your y intercepts. So if you want to pause this and get what you need, the x-intercepts are also the roots or the value that makes the equations true. I would also include that somewhere. But the main parts of all graphs, especially with your parabola, will be the vertex and the intercepts, the x-intercepts and the y-intercepts. Those are usually good values to start with. All right, here you're definitely going to want to pause the video. You need to get all of this, and I even used some different colors when I was doing this. Now, the other thing, I'm going to label this first one here, intercept. Okay, let me write it underneath. Intercept form, because the intercepts you could see in the equation. This is vertex form. Actually, both of these are vertex form because you can see the vertex in the equation. So just pause it, get everything that you need out of it, and then restart the video. And last, for the summary, you're also going to want to probably pause it. One thing I will say, concave up, concave down. Sometimes people struggle with that. Concave up, I think about if you pour water into a cup, if it's concave up, it stays in the cup. If it's concave down, it falls out of the cup. Okay, so now we're going to look at each of the different types of equations that you could get. So if you see the x's, that means you can see the intercepts. All right, so I would start with finding the roots. They're the values of x that make the whole thing equal 0. So what makes x plus 3 equal 0 is when x is negative 3. Now let me maybe just show you this. If I plug negative 3 in for each x, let me just show you why this is true if you didn't know this. This stays 2, this whole thing is 0, and this is negative 4. Well, when you multiply 3 things together, if one of them is 0, the whole thing is 0. So you're truly looking for each x that makes each parenthesis equal 0. All right. I'm going to erase this because we actually need the room to do the sketch. So my other intercept is 1. All right, so it says using the axes intercept and sketch the graph and state the axis of symmetry. All right, so let me just sketch this part here first, because then I think from there it gets a little easier. These are the x-intercepts, +1, -3. Now, if the x-intercepts are where the y value is 0, how do I find the y-intercept? That's where the x-intercept, or the x value, is 0. So basically, to find the y, you plug 0 in for each x. So 0 plus 3 is 3. 0 minus 1 is -1. 2 times 3 times -1. That just means it will intersect the y-axis at -6. The y-intercept, these are your x-intercepts. Okay, if they want the axis of symmetry is the average of the x-intercepts. So the axis of symmetry, first of all, we average -3 plus 1 divided by 2. That's how we find our average. So that's -1. So does it make sense? That's where my axis of symmetry is. Notice this one doesn't ask us to find the vertex. They just want a sketch going through the intercepts where the axis of symmetry goes through the middle. Oh, your axis of symmetry should always be x equals this number. All right, letter B. So first we find our x-intercepts, the values of x that make the equation equal 0. We could find our axis of symmetry right away since we have these two numbers. So 1 plus 2, finding the average, add them together, divide by 2 is just 3/2. You always want to notice they say the equation of the axis of symmetry. It's going to go through the x-axis. See back here? It's going through the x-axis at x equals 3/2. And we can find our y-intercept by plugging 0 in for each x. 0 minus 1 is -1. 0 minus 2 is -2. So this will be -4. Now we're just going to do a basic sketch. So our intercepts are at 1 and 2. Our axis of symmetry goes through the x-axis at 1.5, 3/2. Our y-intercept is here. See, what we can do with that is we can just reflect that over here, giving us a second kind of helping our shape. And just to go through these points. And I'll just tell you, if this is negative, it's going to be upside down. When this number is positive, it'll be facing upwards. Okay, so this only has one x-intercept at x equals -2. So let me just show you. If there's only one x-intercept, it's going to bounce off the x-axis at -2. That means this is my root or my intercept. This is also my axis of symmetry. because this is my vertex. Okay, if this is a quantity squared, your vertex is on the x-axis. So let's figure out our y-intercept. 1/2, 2 squared is 4, half of 4 is 2. So I'm going to reflect that over my axis of symmetry. And notice this is a little bit wider. The smaller this number, the wider the graph. The bigger the number, the skinnier the graph. If this is negative, it goes upside down. This is positive and skinnier. Okay. These get a little less intensive. Okay. So just one problem. It says use the vertex, axis of symmetry, and y-intercept. So when they're specifically asking you for pieces, make sure you address all pieces of the problem. So the vertex, we see the vertex when we start with a quantity squared. See, if you want to look back earlier on that chart, the opposite of this number, -1, is the x-coordinate, and the number being added on at the end is the y-coordinate. So the general equation, a times x minus h squared plus k, where the vertex is the hk. So the opposite of this number and this number, that's where we find the vertex. The axis of symmetry goes through the vertex. So I'm going to label this axis of symmetry, x equals -1. How do we find the y-intercept? That's where we plug 0 in for x and solve for y. So 1 squared is 1 times -2 is -2 plus 4 is 2. We have a whole lot more room for this example. Sorry about that. So we graph -1, 4. Notice because this is negative, it will be going upside down. So all of your pieces should help make sense of that. So y equals 2 is my y-intercept. So I'm going to immediately just flip that over the y. And there's my parabola. So you can use all these pieces to help you shape your graph. Okay, so this is an extra little piece. Maybe just watch me, because I'm going to show you when we start with a general standard equation, how can we make it into the vertex form? All right, and we'll get into this later in the chapter, but I just want to bring this to your attention. So just watch, you don't have to put this in your notes. Okay, so if we were to factor this, factor x squared into x and x, factors of 4 that add to get 4, plus 2, plus 2. So notice these are the same, so I can convert x plus 2 times x plus 2 into x plus 2 squared. These all share the same pattern. So factors of 9 that add to get 6, plus 3, plus 3. factors of 16 that add to get -8, -4, -4. So the pattern that all of these share is that when you factor it, your factors are exactly the same. So you can rewrite it as a quantity squared. This is how we're going to change into vertex form from standard form. Okay, so what is the relationship between this number here and the middle term? 3 and 6, 4 and 8. This number here is always half of the middle term. This number is what we call the number that completes the square. In order for this whole process to work, this number has to be half of the middle term, the linear term, and this last number has to be this number squared. 2 squared is 4, 3 squared is 9, 4 squared is 16. All right, so I'm going to kind of show you how to dig into this a little bit. Once again, this is not in your notes. This was just an extra piece to help with this next process. So we want to convert the x squared and x into vertex form. So what we end up doing, we have to take half of the linear term. So half of 20 is 10. 10 squared is 100. 100 is the number that completes the square so that this trinomial can be rewritten as a quantity square. Half of 14 is 7. 7 squared is 49. Because we're squaring this, it doesn't matter if this is plus or minus. This will always be a plus. This one's trickier. Half of a fraction or half of an odd number creates a fraction. Don't make a decimal. When you take half of an odd number, just keep it as a fraction, because when you square a fraction, you square the numerator, square the denominator. 25 fourths. You can actually square fractions in your head way easier than decimals. So if the x term is odd, just put it over 2 and square it. Square the top, square the bottom. All right, so this process is called completing the square, and we're going to complete the square by getting our standard form into vertex form by completing the square. All right, so copy this down, but we're going to leave room because 3 is not the right number to complete the square, so I'm just going to push it over. But because I have to add something in here to get the same equation, we're going to have to subtract it over here. So bring down the y. We take half of 4, x plus 2 squared. 2 squared is the value that completes the square. Now this is important. This whole thing makes the quantity squared. Because we had to add 4 to complete the square, I need to subtract 4 to counteract it. I can't just change the equation, but I can, if I add and subtract on the same side, it's like I really added 0. But then I can combine these together to get -1. Now it's in vertex form, so I can find the vertex stating the coordinates of the vertex. So my vertex, -2, the value that makes this 0, -1, this is my y coordinate. Then the other thing that we can do, I'm going to write this over here. I would also, if it's possible, I would factor it and find my zeros, my x-intercepts, factors of 3 that add to get 4. So my x-intercepts are -1 and -3. The only thing that it asked me to state is the vertex, -2, -1. But see how if I know my x-intercepts are -1 and -3, there's my parabola. The more pieces of information, you will have a more accurate graph. This only asks for the vertex, but if you can find other pieces to help, it's also good. All right, this one is even more complicated, but take a deep breath. So the problem with completing the square is that you can only complete the square if the x squared does not have a leading coefficient. So the very first thing we're going to do is we're going to factor this 3 out of the x's only, and I'm going to move that 1 over. I'm dividing out everything by 3. So this is where this one gets tough. I'm going to leave room to complete the square, moving the +1 on the outside. Okay, now I'm going to bring down the 3. I want to convert my trinomial into my quantity squared. Bring down the x. This square goes to the outside. How do you take half of 4/3? Half of 4/3 is 2/3. How do you square a fraction? Square the top, square the bottom, 4/9. Okay, here's where it gets a little trickier. If you have an outside coefficient, we have to multiply the 4/9 times the 3, which is 12/9, and 12/9 I can reduce to 4/3. All right, so 4/3 is just 1 1/3, plus this one is 2 1/3. All right, that can be a little rough. You might need a little extra practice with that. But our vertex is 2/3, always the opposite, 2 1/3. I'm going to find my intercepts because this is factorable. So I find my intercepts by putting y, 0 in for y. 3x and x make 3x squared. 1 and 1 minus minus. So my intercepts are 1/3 and 1. All right, so the vertex is 2/3, 2 1/3. So approximately here, my x-intercepts, 1/3 and 1, super skinny because remember, if that number, the bigger that number, the skinnier the graph. This will take us a few days to work through. All right, so the last page, this is just a summary of everything that we're kind of talking through. So if you want to pause the video and sketch this out, we have one last example. So when you're ready, start it up. Okay. So the first thing that I'm going to go back to, the axis of symmetry is the opposite of B over 2A. Very, very important. This is actually in your formula booklet. So this is when it is in standard form. So the axis of symmetry, A equals 2, B equals 8, C equals -10. So I find the axis of symmetry by the opposite of B over 2 times A. So I get -2. So if my axis of symmetry is -2, this tells me where my vertex is. Find the coordinates of the vertex, because this tells me the x coordinate of my vertex is -2. Your vertex, your axis of symmetry have the same value. So I'm going to use my equation and find the y value by plugging in -2 in for the x. -2 squared is 4 times 2 is 8. So my y coordinate of the vertex, -18. All right, my axes, intercepts. Okay, let me just say, they want both the x and the y if they don't specify. If it's in standard form, let me label the y-intercept is just the constant. The x-intercepts we find by factoring. Now, do you notice how 2 is a GCF of the equation? I'm going to divide everything by 2 because this will make it easier to factor. Break apart your x squared. Factors of 5 that subtract to get 4. 5 times 1 is 5. 5 minus 1 is 4. Because the 4 is positive, the 5 is positive, the 1 is negative. So my x-intercepts are -5, +1. So we're going to take all of these. Hence, the reason we found all of these is because I'm now going to sketch everything on my graph. So my x-intercept, or my axis of symmetry goes through -2. My vertex is at -2. I'm just going to go down here and say that's -18. There's my vertex. My x-intercepts are at +1. 1, 2, 3, 4, 5. And there's my graph. Lots of information. If you need to watch this a couple of times, that is fine.